Hi everyone, can you hear me? I hope, maybe.
Yep, I can hear you.
Thank you. Thanks for confirming. So we're a little early by 5 minutes, so I'm going to give us a chance to have some more people join and then we'll get started. Hi, for those of us who just joined, we're going to give it another minute for everyone else, and then we'll get started with our science section review today.
Hi, Annie. How are you?
I'm well.
I'm
How
good.
you
I'll show you
doing?
my little cute kids, and we're ready to get started in just a few minutes. Let's see how many people are in. Okay, good. It should be a good amount. You want to see Annie? Look at Annie. Hi.
Hi.
Hi,
How's it
Annie.
going?
Say hi, Annie.
Bye.
Okay, I'll give you a minute. Michelle, here, put this in the kitchen. We're good. We'll give it another like minute or so they'll add in, okay? Don't forget to sell the class like a lot, okay? Don't forget. Just Annie, make sure that we're selling the class like big time. Okay. Dee, are you okay with your share screen? Is it working? Look. Good. The share screen looks good, right? Good. Yes. You want to tell Annie what you did today quickly? What did you do today? Jessica?
What'd you do today?
What did you do today? Tell her fast everything before she starts Zoom. They went sledding. What else did you do? Jessica, honey, here. You sure? Oh, they did so much today. They had like an action-packed day.
Nice.
It's good
For a snow day.
You think the parents are gonna join on time?
Yeah, we already have a few here.
Okay, let's see.
All right, so we have, I think, 11 participants so far, 12, including me. And then there's another joining.
Let's give another minute or so. Oh, and you know what? I'm also gonna do a record. So can you record in yours? Is that okay? Hit record.
Oh, it's recording, yes.
Oh, good. Perfect. Jessica, honey, go. Michelle, come.
Okay, I'm not seeing anyone else in the waiting room.
Okay, we're good. Great. Hi, parents. Welcome. We're going to wait just another minute to see if there's anyone else joining. Okay, so and students, one more moment. One more moment. Okay. Good. Annie, thank you so much for hosting this meeting. I'm really glad that you're doing this. We're going to get started in 2 minutes, 3, 2.
Okay, some more are signing in.
I think we're good. Actually, the numbers look good. Hi, everyone. I want to say thank you so much for joining. We're so happy that you're here. Annie, I think the best thing we can do right now is if you can tell everyone about yourself and if you can just spotlight yourself in the video. You're gonna laugh. We're actually running a second Zoom in a couple of minutes. So I'm gonna head into that one, but I'm really, really glad that you're doing this. And I'm looking forward, okay? Thank you, Annie. We'll see you in just a little bit, okay? Thank you, everyone. Just make sure you're on Spotlight and you're on record, okay? And everyone feel free. You can reply what you're in. And Annie, you can tell them what class you're teaching and so on and so forth, okay? Go ahead.
Of course. Hi everyone. Thank you for coming to tonight's ACT 2-hour Science Strategies Review. It is taught by me, Annie Q, from 7 to 9. Just a little bit about myself. I have joined Kweller for a while now, and I'm so excited every semester to start a new session helping students get the best score possible for this standardized test. Personally, I've taken it and I've scored a 35 out of 36 scaled. So that I think is a good goal to reach. And we're going to shoot for the perfect stars anyway. Just a little bit about what I do personally. I have a position with Memorial Sloan as a research coordinator running clinical trials. I also have a position with CUNY Hunter College. I am a non-teaching adjunct there. I also now work for Kweller, and you guys are my priority for the next 2 hours. And also, if you would like to join my class, we have our sessions from January 2nd all the way to April 15th. So if you like, just subscribe and join my class. If you have any questions or comments during the lesson, please feel free to use the chat function. I will be monitoring the chat and helping you guys out if you have any questions or comments. Francis, do you have anything to add before I launch?
I just want to remind you that the content that will appear in the ACT is going to help you in several years outside of just ACT prep. So even though the test is optional, just remember the content on the exam is really good. And Annie, if you could just please speak to that about how useful and how helpful the content is in the actual ACT. I think the kids will get a lot out of that. Thank you so much. Please sign up and tell everyone that Kweller Prep is your fave. All right, go ahead.
Okay, so yes, like Francis said, there are many uses for the subjects that are being tested by the ACT. You do have, as I will go over in just a little bit, an overview of the test, but we basically have our English section, our math section, reading, and science. Those, I think, are the most fundamental skills that we need to survive in the world of academia. So once we have the basics down, very strong foundations, we can go ahead and apply that to many different realms, as I did when I was taking the ACT exam and graduated from Hunter College with 2 degrees, human biology and psychology. So there's many applications for what you can do with these different sections from the ACT. I personally have used the knowledge that I got when I took the test in my college classes. So that is super helpful, I think. Everyone should, I think, try it out and do take the test. It will help you out in the future. Anything else, Francis?
No, I think we're good to go. And thank you. And do you happen to know offhand when the course is going to run, the ACT course, and just let the kids know that also?
Okay, sure. So the courses that are going to be offered next year, 2021, it's 1 month away, a couple weeks actually. So we have our Zoom sessions hosted by me from January 2nd all the way to April 15th. We will be doing different sections per week, and also we will have testing supplied to you. So everything is included: workbooks, exams, printed materials, and we will meet once a week for 4 hours. In those 4 hours, we will cover lots of ground, so be ready to tackle it. It's from 8 a.m. to 12 p.m. So if you would like to join, please sign up. This will help prep your students for the April 17th ACT.
Okay, great. Thank you. Thank you so much for doing this, Annie. We really appreciate it. Okay, I'm looking forward to listening for a few minutes. And then, as I said, we have another Zoom that I'm going to jump on. Okay, take care.
Excellent. Thank you. All right, so let's get started with preparing for the ACT test, the science section review by me, Annie Q, for today, December 17th. Hopefully everyone can see my share screen. If you cannot, let me know in the chat. I'll go over the overview of the test to begin with, so we're all a little more familiar with what we're dealing with. The overview of the SAT. So the SAT measures the knowledge, understanding, and skills that you will have for our English, math, reading, and science section. We also have a writing section that is optional for 1 essay, and you will do it in 40 minutes. but otherwise, the English, math, reading, and science sections, you will have a multiple choice format. There will be 4 or 5 answers. You will choose the best answer possible that will address the question with what you have given to you in material in reading or in the math problem. So for English section, there is 75 questions for 45 minutes. Mathematics will take 60 questions for 60 minutes. We will have reading 40 questions for 35 minutes. And my favorite, science, 40 questions for 35 minutes. And again, there's a writing section that is optional, 1 essay for 40 minutes. So how the ACT is calculated, you will get a raw score for each of the sections, the English section, the math, the reading, the science. They will be scaled from a range of 1 through 36. Once you have a scaled score from 1 through 36 for each of these 4 sections, they will be compiled into one composite score, also ranging from 1 through 36. So from the raw score, number of questions you answered correctly, all the way until the composite score, you want to aim to get the most number of questions correct. That way you will boost your scaled score for each section, meaning a boosted score for the composite score. Ways to refresh with Kweller Prep. So we want to get familiar with the content of the tests. As we did a general overview of what the ACT is, I hope that helps a little bit on what you might expect per section in terms of questions and timing. We want to review and note all of the possible areas that will take up a large portion of the test. And once you do that, you can update your knowledge and skills on each content area. Again, that is English, math, reading, and science. And we want to continuously refresh your knowledge. And once we can identify the content areas that you are not familiar with, we can take coursework and help you understand where you are unfamiliar with. So some test taking strategies that Kweller Prep likes to use and have been very successful in the past. So we can use those for the future. Number 1 is to pace yourself. This is quite important as you need to split your time between all of these sections. And within each section, there will be a couple of questions that are towards certain subjects. So we have to split our time between reading passages, answering questions, figuring out your response. So the best way is to create a target time frame. And once you do that, I would like for us to try to leave 5 minutes at the end. So using the remaining time to review your work, because once the timer's up, you can't go back to the previous section. So things to avoid: spending too much time on one passage. For example, if you have 6 passages in the science section, in the science section, we don't want to take over half the time on maybe 2. We want to pace ourselves and split the time between 6 passages. And we don't also want to spend too much time over an answer. We do want to go back onto other questions and come back to problem areas if there is time, which is why those 5 minutes at the end is going to be super important, especially if you might be unfamiliar with certain topics so far. But we're going to work to boost your knowledge and make sure that you answer everything to the best of your ability. So the science test asks for the best answer. We want to read and consider all of those answer choices and choose the answer that best responds to the question. And how are we going to do that is we will read questions very carefully, understand what the question asks. Some questions require several steps. You will see in just a little bit as we go over a science section. Some questions are more straightforward than others. So definitely take your time to understand the question, making sure that you go ahead and choose the best answer that will address the question. So we want to rack up the points. That is a good technique because we want to make sure that we get the most questions right out of each section. We want to answer the Easy questions first, skip the difficult ones. We will come back to them once we have a little more time towards the end. We have to use some logic on difficult questions. So a couple of things we can do is process of elimination. We will try that later on. We will compare the choices as well, and we will try to make an educated guess if all else fails. So we want to prevent all else failing. So we will substitute everything for your knowledge as best we can at Kweller. So again, we want to answer every question. Your score depends on the number of questions you answer correctly. There's no penalty for guessing, meaning that if they find out that you guess, oh, do they take off a point? No. You want to try to fill in all the answers within the time allowed for each test. As I mentioned before, you can't go back to a section once the time is up for that section. If you have time left for that section, check your work. This is why the 5-minute time frame is super important. You can't mark responses to a test after the time is called, so make sure everything is bubbled in as best you can. We want to be precise when we're bubbling the answers, making sure that the number on each line of the ovals matches the number of the question you're answering. You can change your answer, yes, but make sure you erase completely. Do not cross out answers. That will trigger the Scantron sheet to be marked wrong. Do not use correction fluid or tape. We just want to use our eraser and make sure that we remove the mark completely. Make sure there's no smudges either, so we don't want an accidental grading error. So get ready. We know what to expect. We can take practice tests as we will offer in our January to our April class. For every couple of weeks, we will take a practice test. We will go over those sections in depth each time, making sure that you get plenty of rest the night before the actual test. Please, please, please rest your brain. It's very important. Review the test day checklist as well. So you will have these two links. ACT.org, the ACT checklist, which is super important, making sure you have all your materials to take the test successfully, verifying who you are, your credentials, and if you need more information, the actstudent.org site is pretty helpful as well. Now, down to our content of science section. Let's see what we have. So science test is 40 questions in 35 minutes. The subject areas covered are going to be biology, chemistry, earth and space sciences, and physics. What they want to measure is how well you interpret, analyze, evaluate, reason, and solve some problems. So what material you have to work with are authentic scientific scenarios. Then they give you a couple of multiple choice questions to evaluate that scenario. Advanced knowledge is not required, but background knowledge in general introductory science may be needed. So if you have something, we'll show you in just a little bit. If you have a foundational knowledge in science, that is very useful, but we also want to put it into the specific scientific scenario that the ACT provides you. Now, the focus is the multidimensional assessment. We want to recognize and understand basic features related to the provided information, which means we need to critically examine the relationship between the info provided and the conclusions drawn or hypotheses developed. So we also want to generalize from given information to gain new information, draw conclusions, or make predictions. So there might be some light math involved, but you're not allowed to use the calculator on the science test. Only in the math section you're able to. So what do we have for each of the 40 questions? Each of these passages will be made up of different parts. We have data representation. What does that mean? We have graphic or tabular material. So it's very similar to what's found in science journals and texts. So on the screen, you'll see on the left-hand side, there's a table. On the right-hand side, there's a graph. We want to measure the skill of interpolation, and extrapolation, translating what you have on the table or graph into a singular answer, which will address the question that they would like for you to evaluate. Next part, we have research summaries, descriptions of one or more related experiments. So you will see in our presentation a little bit later how they will have different studies. We will have study 1, 2, and 3. We can focus on the design of the experiments and interpret each of these experimental results. So we want to make sure that we go ahead and read those research summaries very carefully, as each study may be different from each other. There may be also conflicting viewpoints where there are 2 or more explanations for the same phenomena that are inconsistent with each other. So you will be able to understand and analyze, compare alternative viewpoints after reading what the passage has to offer. So they will generally give you a basic structure of facts first, and then they'll show you different interpretations of it from student 1, student 2, and so on. So again, as review, we have interpretation of data, scientific investigation, evaluation of models, inferences, and experimental results. That's what the entire science test is made up of. Once you break it down into these 3 sections, it's not so crazy. Tips and tricks for the science test. As we went over a little bit before, read the passage very carefully, meaning that we need to consider the scientific material, read the entire text, examine all the tables, graphs, and figures that they gave us, and we want to annotate important ideas and consider the experimental design as a whole. We want to note the different viewpoints in the passages. Some material will give us conflicting viewpoints, and questions will ask you to distinguish among them. Summarize each viewpoint next to that section in the test booklet, and you'll have an easy reference for what they might be. And you can go back to that section very quickly when you notice that they're asking for it on the question. So, breakdown on the science section scoring. Again, there are 3 reporting categories. So you will have a couple of questions on interpretation, scientific investigation, and evaluation of models. This will add up to your science section raw score, meaning what you get correct out of the 40 questions. The score will be scaled to a range from 1 to 36. And then the scaled score will be added together with the other sections to create a composite score, which is also from 1 to 36. Ready to try together? I see in the chat someone said 99% of the problems aren't straightforward. Let's try to get them straightforward. We will go over some material, and hopefully that will help ease your brains, and we will go ahead and confidently answer the question. So we have a passage 1. I have a question for everyone. If you can confirm that you have this material, did Frances, was she able to send you a packet? Let me know in the chat. If you don't have it, I can upload it to the chat so everyone can download. What's happening? Does everyone have it? It starts with, a study was conducted to examine whether female Blatella germanica. Don't have it. No problem. I will send it in just a second. 1 second. I would like for everyone to be prepared. So let's have this. Science review. 12. Okay. What did I send us? Okay, so I'm going to upload into the chat the packet so you can reference the questions that I'm going over at your own pace for later. There's practice questions for you guys. There's homework. There's take-home things. So you can go ahead and access the chat. Preparing for the ACT, the 2020 guide, science review. All the information that I went over on the PowerPoint is also nicely packaged into the PDF. So again, if you can go into the chat, you can open it up and have the entire science section available to you to go over with me, and then we will have some homework that you can do at your own pace. So does everyone see in the chat the PDF? I hope everyone can get it. Let me know. Yes? No? Downloaded? Got it. Wonderful. Not yet. Okay. Okay. So I sent it to everyone, but Ryan's mom, let me try to send it to you. I will attach it one more time for everyone. Okay, so again in the chat, you'll see the PDF for the material that I'm going to go over just now. So if you have a chance, we can download that, or we can follow along on my screen that I'm sharing. The first passage begins with, a study was conducted to examine whether female Blatella germanica, a species of cockroach, prefer to eat cat food, cheese, ham, or peanuts. Interesting group of food. So first, 200 milligrams of each of the 4 foods was separately placed into a single box. Then the adult female B. germanica were added to the box. Figure 1 shows how the mass in milligrams of each food in the box changed over time after the addition of the cockroaches. Table 1 shows the percent by mass of carbohydrates, lipids, proteins, and water respectively present in each of the 4 foods tested in the study. So right underneath, you have a figure 1, which is showing what cat food, cheese, ham, peanuts were doing over the time length of 0 to 28 hours, how the mass changed over time. And then on the right-hand side, you have up top a table breaking down the percent by mass of carbohydrates, lipids, proteins, and water. Peanuts are surprisingly more nutritious than cat food. Yes. We have cat food, cheese, ham, and peanuts. So let's go over our first question. According to figure 1, the mass of cheese remaining at the 4-hour mark was closest to which of the following values? So what are we looking at? We're not looking at the table. We're going to focus on the figure. And we will focus on that 4-hour mark, how much of the cheese was remaining. So what do we have? We can follow along. You can answer in the chat. That is all right. I'm going to go ahead and let you in on the secret. The answer is C, 185 milligrams. How did we get here? We want to look at figure 1, of course, focusing on the 4-hour mark, looking at a certain shaded or blank bar, and they're asking us about the mass of cheese. The cheese is going to be the unshaded one, so let's look at that. We can see that in the 4-hour time period of these 4 food groups, we have our cheese right there, and it sits at the top, the tippy top of the bar. We can horizontally draw our imaginary line to the y-axis, the mass of food remaining. We will see that is a little bit elevated over 180, but not quite yet to 190 or 200. So it should be the answer closest to 185. All right, so that wasn't so terrible, right? The next question, what about number 2? Suppose a company wants to use a food as bait in a trap designed to capture female B. germanica. Based on figure 1, again, we're focusing on figure 1, which of the 4 foods should the company place in the trap to maximize the chance of capturing these cockroaches? So what should we look for in the food? These 4 foods, cat food, cheese, ham, and peanuts. If you start off with a lot of mass at 200, that's what they're originally, and we want to see which one attracts the cockroach the most. So meaning that they would eat it the most. So of the answer choices, which one might work? All right, so our best answer is going to be J, peanuts. Why? Because we're looking at how these bars decrease over time from the 0 mark to the 28th hour mark. And which one of these bars, cat food, cheese, ham, peanuts, which one of these decrease the most? That way we can know for sure that the B. germanica ate it the most, which means that it's most attractive. So it'll be best used to capture them. So over these 4 bars, we see that peanuts seems to have the most success. So that answer choice is J. All right, 2 warm-up questions. We have number 3 next. Consider the 4 foods in order of the percent by mass of proteins from lowest to highest. PDF again, sure, Mia, I can. There we go. Okay, so from food to food, as the percent by mass of proteins increase, the mass of food remaining at the 28th hour did what? So we have a couple things to consider here. We have the table. Yes, we need the table now. And the figure 1, the graph. So we need to look at the percent mass of proteins and what happened at the 28th hour. So our answer choice B best reflects what the question is asking for and what it wants you to address. Why? Because we're looking at 2 things. Proteins on the right-hand top side, as it goes from cat food to peanuts, it is increasing 16.9, 20.8, 23.6, 26.2, and it just keeps getting higher. And then we'll see how it goes over time until the 28th hour. This question is asking about the trend. What happens to the food as time increases? As time increases, the food mass will decrease. So starting from 200 milligrams of each of the 4 foods, we are going to slowly see the B. germanica whittle that away until the 28th hour. As we said before in the question, the peanuts seem to be the most successful amongst these cockroaches. So let's move on to number 4. Let me know in the chat if I'm moving on too fast. I get so excited about the science section because that's my deal. And that's my favorite section of the 4. Just slow me down if you need me to slow it down, okay? So number 4, consider the statement, the B. germanica ate the food between 0 hour and 4 hour, between 4 and 16, 16 and 24, 24 and 28. So this statement is consistent with the data in figure 1 for how many of the 4 foods. We want to see that the B. germanica is eating the foods, meaning that the 200 milligrams will decrease. And is that true for all of the food types? That's the question we should be asking ourselves. So we want to interpret the question and make sure that we know what components to look for. And our answer here is going to be J, 4. Why is it 4? Looking at each of these 4 foods grouped at the 0, 4, 16, 24, and 28th hour mark, we see that it's decreasing. Why are they decreasing? The roaches are eating the food. There will be less of it left over. And we want to make sure that the statement, as it says, eat the food, matches up with the data, which it does for all 4 points of cat food, cheese, ham, and peanuts. So again, we didn't need table 1, we just needed figure 1. Okay, next up, we have number 5, a lengthier question, but not too crazy. A student predicted that the B. germanica would eat less cat food than ham by the end of the study. Do the data in figure 1 support this prediction? So this question, you need to look at two things. First part is yes or no. Second part is the reasoning to support your decision of yes or no. So there's those two parts that need to check out, need to be true, and need to be best supported by the figure 1 as they ask us to reference. So the prediction was the cockroaches would eat less cat food than ham by the end of the study. We need to identify the bars that show cat food, which is the darkest shaded one, and we can look at the ham, the bar that is light gray shaded. So does it seem that they're eating less cat food than ham? And looking at each of the 0-hour versus the 28-hour mark, what is the milligrams left over, right? So more cat food than ham. The answer is yes. At the 28th hour, yes, JG, yes. The mass of the cat food remaining was about 55 milligrams greater than the mass of ham remaining. Okay, so less cat food meaning more left over. That is true. We see a higher cat food bar than the ham bar. And how far away is that? We will see that cat food is at about 170 and ham is about 130 or so. We subtract and that's why we get 55. Okay, number 6. Based on table 1, we're shifting our focus to table 1 now. When 200 milligrams of each of the 4 foods was placed in the box, water accounted for more than 100 milligrams of the mass of which foods? So 200 milligrams of each food and water accounted for more than 100 milligrams of the mass. What's the relationship there? We want to see that, hey, the water accounted for more than half of the mass, more than 50%. So in table 1, we will locate the correct column and see what is over 50%. Our answer here for number 6 is going to be G, cat food and ham only. Because when we're looking at percent by mass, the water section, the column of water, we see that the cat food is 66.2% and ham is 57.1%. So you will have those values over 50% of what the food is composed of. Food again was 200 milligrams and 100 milligrams of the mass, which is water, meaning that 50% of the food was water. Okay. So we need to find something that is over 50%, which is cat food and ham only. Now, a different passage. So I got tired of roaches. Let's work on passage 2. This is about a science class and samples from A through H. Students were told to assume that each sample is a completely solid cube composed of a single hypothetical pure substance. So we have a table here detailing sample A through H, what the mass, volume, density, melting point, and boiling points are for each of them. Then the teacher asked the 4 students to explain how these data could be used to predict which samples are composed of the same substance. So out of samples A through H, which ones may be the same substance? We have 4 different viewpoints. Student 1 says, if 2 samples have the same values for all 5 properties, they're composed of the same substance. If 2 samples have different values for any of the 5 properties, they're composed of different substances. Okay? So student number 2 has a different point of view. Student number 2 says, if 2 samples have the same values for any 3 or more of the 5 properties, they're composed of the same substance. If 2 samples have the same values for fewer than 3 of the 5 properties, they're different. Okay? Student 3 and 4, also different viewpoints. Student 3 says, if 2 samples have the same mass, volume, density, so specifically mass, volume, and density, they're composed of the same substance. However, if the two samples have different values for any of these specific three properties, they're composed of different substances. Student number 3 doesn't say that melting point or boiling point matters. Neither melting point or boiling point by itself can distinguish between substances. Finally, student number 4 says if two samples have the same density, melting point and boiling point, okay, again, 3 specific points, they are composed of the same substance. If two samples have different values for any of these 3 properties, they're composed of different substances. So this student says neither mass nor volume by itself can distinguish between substances. Okay, fine. Let's look at some questions. Based on student 1's explanation, the same substance composed of both of the samples in which of the following pairs? Wow. Okay, so we have a limited range of pairs we have to evaluate. We have A, B, B and C, C and D, D and E. We don't really care about F through H just yet. And then we'll locate student 1's explanation. Based on what student 1 said, which of these choices, A through D, samples A and B, B and C, C and D, D and E, which of these pairs seem to be composed of the same samples? C and D, okay. Okay, answers coming in. C and D. Okay, moment of truth, here we go. The answer is yes, C and D. How did we figure that out? We want to look at student 1's explanation and see that, hey, if two samples have the same values for all 5 properties, so which of these samples have mass, volume, density, melting point, boiling point? All of them are the same. And the only answer is C, samples C and D. Very nice. Okay, so far so good. And we shall move on to our next question. Okay, based on student 3's explanation, the same substance composes both of the samples in which of the following pairs? So again, we're looking for pairs, but this is based on a different student's point of view. We have student 3's explanation saying that if the two samples have the same mass, volume, and density, so 3 specific elements, they're composed of the same substance. Okay, so which of the following pairs work for that explanation? A and C, B and E, F and G, or G and H? I'm going to take some time to look at each of these samples, matching up what pairs are compared, and look at the columns of mass, volume, and density. Okay, answers coming in. I'm seeing a lot of G and H. Okay, so moment of truth reveals. Yes, it is samples G and H. You guys are killing it today. All right, why did we get samples G and H? We want to look at the mass, volume, and density, so 3 columns, 3 of the first 3 columns, and see if they match for each of the pairs that they gave us from answer choices F to J. And it seems like only samples G and H fit that explanation. So you see so far how we pick apart the question, look at what they want us to reference, and take that information out from the text itself, right? Okay, super. Oh, what about C and D? Okay, let's look at C and D. C and D seems that we have, yes, 6 for mass for both, 3 for volume, 2 for density. Yes, C and D, they do have the same of those. However, they are not offered in our answer choice pairs. So yes, if they had another group saying samples C and D, that would also be true. But of these answer choices that they gave us, we need to choose the best answer from that group. But you're not wrong. C and D, yes, they do have the same mass, volume, and density, meaning that they're composed of the same substance. This is also true for G and H. Okay, so if they're not offered in the answer choices, we can't pick that answer. So we have to see what is offered and what is the best choice out of what is given. Okay, how about number 9? Suppose that the temperature of sample A is increased to 250 degrees Celsius at 1 atmosphere pressure. At 250 degrees Celsius, would sample A be a solid or liquid? So a different part of the table we need to examine. Not the mass, not the volume, not the density, but we're looking at the melting and boiling points. That should tell us if it goes from a solid to a liquid or a liquid to a gas or a solid to a gas. So remember the previous text said, hey, each of these samples were a completely solid cube. Okay, so it says sample A, first row, increased the temperature to 250 degrees Celsius at 1 atmosphere of pressure. What would it be? Is it above melting point? Is it above boiling point? Is it below either one of these? So what would it be? Would it be a solid? Would it be a liquid? And again, this question is 2 parts. You want to say if it's a solid or liquid and follow up with the reasoning. Okay, so some thought into that. So 250 degrees Celsius, where does it fall? Right? So our best answer is going to be out of the ones given. It's going to be C, liquid, because the melting point of sample A is 126. And it's not quite at the boiling point, which is 747. So it won't be a solid anymore once it melts. So it goes from its solid state to the melting point of 126, but at 250, it would have been already melted. Right, so these are the important things to look at. Row of A, looking at melting point and boiling point only, and comparing it to what 250 degrees Celsius means for the sample. Okay, number 10. Consider the claim that 2 samples having the same density will be composed of the same substance, regardless of the values of the other 4 properties. Okay, so it says same density means same substance. Which of the students, if any, would be likely to agree with this? So we want to match the students' views, 1, 2, or 2, 3, and 4, or all of the students, or none of the students. Does anybody in the students section say that, hey, if it's composed of the same density, they will always be composed of the same substance? Do we have any matching statements? You need to evaluate all of student 1, 2, 3, and 4. And it turns out when rereading student 1, 2, 3, and 4's views that, hey, none of these students agree with the claim. Why? Because we says regardless of the values of the other 4 properties, nothing else is considered except for density. And these students, none of them say, hey, we'll look at density only. Okay. 11, coming straight up, which of the students 2, 3, and 4 would be likely to agree that sample A and sample B are composed of the same substance? Okay, looking at the rows of sample A, looking at the row of sample B, which of these students might think that they're composed of the same substance? So let's see what they have for similarly, right? Mass, volume, density checks out. Melting point, boiling point doesn't quite check out. Okay, so it's asking us to find the best fit, right? So let's evaluate what we have here. So I'm seeing lots of different answers. Let's go over why it should be A, students 2 and 3. Okay, so 2 and 3, what does it say? We have to look at the mass, volume, and density. Student 4 says density, melting point, and boiling point. those aren't the ones that are the same. It's not similar because we have melting point, boiling point of different values for sample A and B. But student 2 says for any 3 or more of the 5 properties. So it could be any of these 3, meaning it could be mass, volume, or density. Then student 3 says mass, volume, or density exactly need to be the same for it to be composed of the same substance. And student 1 isn't even mentioned in the answer choice, so we don't need to look at student 1. But of these 4 answer choices, we have student 2, 3, and 4. Looking at all of these guys, it seems that what the table gives us, sample A and B, they have the same mass, volume, and density. So any of these student views that matches mass, volume, or density, or 3 or more of the 5 properties, those 2 would work. I hope that makes sense. Okay. So that was the reason why it was A, students 2 and 3 only, breaking down what is similar. The mass, volume, and density are the same. So we want to look for any of these student views that reflect that. Okay. Okay, consider these statements. 2 samples that have the same mass, volume, density, and boiling point. Okay, so 4 different categories that we'll look at are composed of the same substance, even if 2 samples have different melting points. Which of the students, 2 and 4, if either, would be likely to agree with this statement? So this wants to ask which of these students, 2 or 4, or both, or neither, agree with the statement that 2 samples that have the same mass, volume, density, and boiling point are composed of the same substance. So which of these students, 2 or 4, or both, mentions anything about mass, volume, density, and boiling point to be the same? Okay, answers coming in. Moment of truth. If you guys had a chance to answer, the correct response would be yes. Yes. Student 2 only. Why? Because let's read what we need to consider. So firstly, we need mass. Then we need volume. Then we need density. Then we need boiling point. Okay, so what comes close is student 2's point of view, that says, hey, you know, the same values for any 3 or more of the 5 properties. Not specifically what properties, but any 3 or more, which means 4 or 5 works as well. And then student 4 says same density, melting point, and boiling point specifically. That doesn't match up with what the statement says. So only student 2 would agree with this statement. Yes, you guys are totally getting the hang of it. So for science section, we need to think critically about what the question is asking, making sure we evaluate all parts of the answer and all parts of the question. All right, number 13. Suppose that the temperature of sample D was increased to 890 Celsius at 1 atmosphere of pressure. Will the sample's density be lower than or higher than it was at 20 degrees Celsius and 1 atmosphere of pressure? So they're not changing the pressure. Fine, we're not looking at that. But we want to consider the temperature. Okay. So here again is a two-parter. We want to answer if it's lower than or higher than and follow up with the correct reasoning. Okay, so looking at sample D, we have our melting point at 237, our boiling point at 885. So what happens to the sample? Does it melt and become a liquid? Does it boil and become a gas? What happens at 890 degrees Celsius? And how does that affect density? Is gas denser than liquid? Is gas denser than solid? Or is it the reverse relationship? So all of these answer choices, give it a read. Do we have lower because something, higher because something else? Our best answer for number 13 would be, hey, lower. Sample D will be a gas, and gases generally have lower densities than do solids. How come? Let's look at sample D. We want to look at the boiling point, saying that it's 885. That's when it starts to boil. However, the temperature was increased to 890. So that means it's past boiling. It's been converted into a gas. And what happens between gas and solid in terms of density? Gases will have lower density than do solids. So that reasoning checks out based on what we have on the table. Okay. So far, everyone is okay, following along. Let me know again if I need to speed up or slow down. I just really love the science section, so I'm gonna breeze through it. But we will examine each question very critically. So let's head on to a third passage. A third passage looking more at the chemistry variety. So we have when a solid metal M, such as iron, so they'll abbreviate what the elements are supposed to be. Nickel or zinc is placed in an aqueous hydrochloric acid solution. The reaction that produces H2 gas occurs. And they gave us a nice little equation, a balanced equation for us to look at. Solid metal, 2 parts of hydrochloric acid solution, 1 part of that, and then fine. Okay, 2 experiments were conducted to study the production of H2 in this reaction. The apparatus shown in the diagram below was used to collect the H2 gas produced in each trial. So you have a neat little diagram here explaining in visual properties what this experiment looks like. As H2 was produced in the stoppered flask, that triangle looking one, it exited the flask through the outlet tube and it would displace the water that had been trapped in the inverted graduated cylinder. This is because the H2 didn't dissolve in the water. The volume of the water displaced equal the volume of gas, H2, and water vapor collected. Okay, so here's the important part in addition to what we just read. In each of the experiments, each trial, steps 1 through 3 were performed. So these 3 steps were constant throughout everything. So the apparatus contents were kept at selected temperatures throughout steps 2 and 3. The atmospheric pressure was 758 throughout all 3 steps. So here gives you an idea of what happened step 1 through the rest of the experiment, each trial. So keep that in mind because some of the questions will ask you to come back and say, hey, what's different? What's different between each of the trials? Okay, some more information. They gave you, hey, experiment 1, what happened here? In each trial, selected mass of iron, nickel, or zinc was tested at 30 degrees Celsius. Figure 1 shows us that. Each of these lines are a different metal. We have iron up top in the solid dot. We have nickel in the middle with our unshaded square, and then our triangle is going to be our zinc. So they tell us what happens at each different mass, what type of volume of gas was collected in milliliters, and how it works throughout increasing the mass, increasing the volume, what's happening. Then there was experiment 2. In each of the trial, 0.3 grams of iron, nickel, or zinc was tested at a selected temperature. Figure 2 tells us all about that. We have different temperatures ranging from 10 to 50 degrees Celsius and how much of the volume of gas was collected. Again, the shaded circle is going to be iron, the square is nickel, and the triangle is zinc. Okay. Keeping that in mind, let's look at the next question. Consider the volume of gas collected in the trial in experiment 2 for nickel at 30 degrees Celsius. Okay. The same approximate volume of gas was collected in trial in experiment 1 for what mass of nickel? So this asks you to bounce between 2 figures. for experiment 2 and for experiment 1. We need to locate nickel, first of all. Then we need to locate where it happens in experiment 2 at 30 degrees Celsius, and then translate that to what happens in experiment 1, the volume of gas. Okay, so take a look in experiment 2 versus experiment 1, how that's connected, and how we can use that information to get the volume of gas collected in trial for experiment 1. And our correct answer is going to be H, 0.30 grams. And why is that? Let's look at a couple different things. Firstly, locate which line we're going to look at, the one with the square. And experiment 2, it says nickel at 30 degrees Celsius. Going up from the x-axis to that square point, we see that on the y-axis, it looks like it's a little under 130 milliliters of gas. Then we'll use that by 130 milliliters of gas on experiment 1. We follow it over until we hit one of those nickel data points, and we look down to the x-axis saying that it is 0.3 grams that was collected for the nickel portion. Not looking at iron or zinc, just nickel. Okay. So you see how this is a two-parter. Last time we worked with just one figure or one table, but this one asks you to interpret data points from one experiment and apply it to the other experiment, and finally getting the value to answer the question. So it's getting a little more tricky as we go on, but it shall not stop us. We will press on to number 15. Okay, so how many temperatures were tested in experiment 1? How many temperatures were tested in experiment 2? Again, looking at the difference between 1 and 2, and how many temperatures was used? Okay, experiment 1, what was the temperature or temperatures? Experiment 2, same question. What's the best answer? So a lot of 1s and 5s. So we want to match up exactly what letter corresponds to the correct number per experiment. Okay, answers coming in, love it. Okay, best answer is going to be B. Yes, you answered B, you are correct. Why? Because we're going to see that experiment 1 only uses 30 degrees Celsius. Experiment 2, however, uses, I'm missing an arrow, 1, 2, 3, 4, 5 data points. So at experiment 2, that was tested for 5 different temperature points. So match up, experiment 1, 1 type of temperature, experiment 2, 5 different points of temperature. Okay, how about number 16? Which of the following statements describes a difference between experiment 1 and 2? Okay, so in experiment 1, what happened that was not happening in experiment 2? Something different, something different. Let's look at the answer choices. F says only iron was tested in experiment 1. Was that true? I'm seeing lots of different metals, so that wouldn't be right. Why didn't I add 1? 9 is tricky. Okay, so yes, we have answers coming in. Good. Okay, now we have our answer is J. Yes, you got it right. Multiple mass values of each metal were tested, but in experiment 2, the mass value of each metal was tested, same mass value. And we get that from looking at the experiment 1 first, then consider the experiment 2 second, and we'll see that each mass as listed on experiment 1 was 0.2, 0.25, 0.3, 0.3, and in experiment 2, only one mass value was tested, 0.3 of each. Yes. Okay. Why didn't they add 1, 9 as a trick answer? Well, the ACT is not supposed to trick you. This is why I said it was straightforward. They don't typically put just different answers that might confuse you. It's just critically reading the answer choices and matching it up to what's given to you in form of data. There are 9 scale values at the bottom. Yes, there are 9 scale values at the bottom of the temperature side in experiment 2, but the data points show only at 10, 20, 30, 40, and 50. Would have been the perfect trick answer, yes. Okay, number 17. Which of the following variables remain constant throughout both experiments? Okay, so what's the same now? What's the same? So take a second, look at both experiments, find the similarities. Is it atmospheric pressure? Is it mass of metal? Is it temperature? Volume of gas collected? This one, we can use several approaches. We can do a little process of elimination. We can do, yes, I'm seeing answers coming in. We can do a little bit of exploring per experiment. And our correct answer is going to be A, atmospheric pressure. Why? Remember that little blurb? It said, in each trial, the experiment steps 1 through 3 were performed. And it tells us at the bottom, the atmospheric pressure was 758 throughout all 3 steps. So we can use that information. All of the parts of the reading were important. So coming from experiment 1 and 2, you can also eliminate things. Remain constant throughout both experiments. Mass of metal, we have different masses in experiment 1, although we have the same mass in experiment 2 for all. So we can cross that out. Temperature, different temperature exists in experiment 2, although one exists in experiment 1. Volume of gas collected, you can see that we have different data points per volume of gas, right? It shows that some of it was by like 105, some of it was by 142, and we have all these different volumes of gases that were collected. What is the same is the atmospheric pressure as referenced in the previous experimental steps. Okay. What about number 18? If a temperature of 5 degrees Celsius had been tested in experiment 2, so forget about experiment 1, we're on experiment 2, would the volume of gas collected for zinc more likely have been greater than 107 milliliters or less than 107 milliliters? Two-parter. Is it greater than or less than? And what's the reasoning? Both parts have to match up. In experiment 2, let's look at 5 degrees. Hey, it's not on the scale, but we can interpret, we can see the trend, right? What happens as the temperature decreases from 50 to 10? What's happening with the volume of gas? Seems like it's going down. So what would it be? Greater than? Less than? So our best answer here, seeing answers coming in, best answer here is going to be less than, because for a given metal, the volume gas collected decreases as temperature decreases. And that's true. Let's look at all of them. What's the trend? Iron, nickel, zinc, all of these guys are swinging down. But since we're asking just about zinc, let's locate that bottommost line. It seems like it's going to be less than 107, less than what's happening at 10 degrees Celsius. Okay. I hope we're getting more equipped to answer these science questions. Okay. So consider the balanced chemical equation in the passage. Remember they gave us that lovely equation from the start? Based on this equation, if 10 moles of hydrochloric acid solution are consumed, how many moles of H2 are produced? So locate which elements they're talking about, which parts of the equation. We have 2 moles of HCl yielding 1 mole of H2. What's that relationship? If I had 10 moles of HCl, what happens to the H2? So what's our answer? If I had 2, it goes to 1, but if I had 10, what does it end up with? Best answer here is going to be, hey, 5. How come? Let's look at this relationship. What's the ratio? We have 2 of HCl yielding 1 H2, meaning that is a 2 to 1. If I had 10 moles, what's half of that? It's 5. So 5 moles of H2 are produced. 20. Suppose that the trial in experiment 1 with 0.25 grams of zinc is repeated, except that the inverted graduated cylinder is replaced by inverted test tubes, each completely filled with 60 milliliters of water. Based on figure 1, how many test tubes will be needed to collect all the gas? Okay, let's locate the right metal. Zinc, that triangle one, okay, at 0.25 grams, find that spot. Okay, and then what volume of gas was collected? And how many test tubes can I fill it with? If each completely filled with water is 60 milliliters. So that tells us something about the test tubes. How much can the test tubes hold? That will help us determine how many test tubes we need. So the best answer for this question is going to be G, 2. How come it's 2? Okay, so let's look at zinc firstly at this 0.25 grams mark. And 60 milliliters of water is going to fill up that test tube. Locate what the volume of gas collected was at the 0.25 gram zinc mark. Seems like it's about 100 into test tubes that will hold 60 milliliters of water each. So let's do some nice division. 100 by 60, not a perfect number, but it shows us that we need 1 test tube of 60 milliliters of water and some of another test tube of a little less than 60 milliliters of water. So it'll be 2 test tubes that you can use to capture all of the gas. Okay. Ready to try by yourself? Let's try something for passage number 4. Do you guys have the packets? Again, I can send it one more time in the chat. If you don't have the passage, let me know. Let me know if you need the packet one more time. Everyone has a packet? Okay. So let's try some of the questions on our own for passage number 4 and see where we get. And if you guys would like to self-grade, there's a scoring key on the last page of the preparatory material. And let's try passage 4 by ourselves. Let's see how far we get. I'm going to share my screen for what it looks like, the package. Okay, so that's what we have. So passage number 4, we have a couple of different things talking about circuits now, power supplies, electric currents, a different figure 2, figure 3, and different relationships. Let's see if we can answer from 21 all the way through 26. I'll give you guys 21 through 26. I can give you guys about 7 minutes. What do you guys think? We can do 7 minutes. That's roughly about the time we should be spending, but since we are joining for the first time or earlier time, let's try. Let's try. Okay, so a little sample of what I do for my students when we're taking practice exams or practice questions. I usually put a Google timer up. So when I have the Google timer up, everyone can see the countdown. All right, so for those of us who just joined, I went over a couple of strategies and went over a couple of questions for some practice science work. If you need the package, I'm going to send the PDF in the chat one more time for those of us who just joined, and I will start the timer once everyone's ready and you can pull up the PDF and follow along. We are on page 17, passage 4. We're going to do questions number 21 through 26 in 7 minutes. This includes reading. So we want to gather the most information we can and answer those questions in 7 minutes. Here we go, putting the timer to use. Let's start. Remember, read the passage, consider all the parts, and consider what the question is asking. Then we choose the best answer out of the 4 choices they give us. So again, for those of us who just joined, I have in the chat, preparing for the ACT Guide Science Review. If you can access that, please download. If you can't access that, let me know in the chat so I can send it one more time. We're on page number 17, passage number 4, and we're answering questions number 21 through 26. And a Google timer is up, so you know how much time you have left. Sure, I can send it again. All right, let me know if you got that. All right, after you read the passage, you want to make sure we can answer 21 through 26 the best we can. Didn't get it. Okay. Let's try. If you didn't get it, let me know what your email is in the chat. I can see it, so I can send you directly to your inbox what we're working on. Let me know what your email is, and I can send it to you in 2 seconds. Sure, I can send that to you right now. Okay. All right, should be in your inbox shortly. And do let me know if you don't see it. We can try a different way. Okay, so we're counting down 3 minutes left. We should be about halfway through our questions. Let's see. Let's see what we can do with our last 3 minutes. If you finish early, you can chat me any questions you might have about the test, concerns, science section questions, let me know. We will go over each question as we did on the PowerPoint. Great, great. Good that you got it. Okay. Again, we're on page 17, passage number 4. And again, this is just a little countdown technique that I use with my students. So if you're going to be signing up for my January through April class, we will see during our mock tests that we have a Google timer counting down so we can pace ourselves effectively and see how much time we need on each question or each passage. Okay, so less than a minute left. I'm seeing some answers come in. If you would like, you can type out what you got for each question, 21 through 26. But we will review and see how we did. Coming on to our last 30 seconds. If you need, look over your answers from 21 through 26. This is not the real deal yet, but if you join my class, you'll see how we pace ourselves perception, answering these questions, using our critical thinking. Okay, time is up. How did we do? Were we able to finish? Do we need more time? This would be a good gauge for you to see how well you can answer questions within a time frame. So how about let's go over this? I see a couple of answers for all of the questions. Sure. Let's go over what we have. Let's go over what we have. So firstly, in passage 4, this is about an RLC circuit. The circuit has a power supply, 3 components, R for resistor, L for inductor, C for capacitor. Okay, how do these 3 components work? They gave us a figure 1 in how they connect. Electric current can flow through the circuit either clockwise, positive, counterclockwise, negative. Now, figure 2 here shows the electric current in the circuit where we have amperes and we have power supply voltage during a 20 millisecond time interval. And then in figure 3, we have voltages across components respectively during each change during the same 20 millisecond time interval. So we're looking at the same time interval, but different components of it. Let's see. 21. According to figure 2, maximum positive value of Vs was approximately. So figure 2, let's pull that up. Figure 2. Maximum positive value of Vs, which is a dotted line. Let's see. What is the maximum positive value. So if anything above 0 but their most highest point, our peak is going to be what voltage? Correct answer is going to be C250. Why? If we look at the top, the tippy top, the peak at around 8 milliseconds, tracing it in our imaginary line all the way to our right-hand side, it's between 200 and 300, roughly at the middle mark, at the 250 mark. So yes, C is correct for number 21. 22, a period is the time required for a wave to complete one full cycle. Based on figure 3, the period for VL was, okay, so figure 3 now, looking at VL, which is the larger dotted or dashed line rather than the dotted line. So let's see, was it 5, 10, 20, or 40? So period as it is defined is the time required for a wave to complete one full cycle until it repeats again. So we want to see where it starts and where it stops. Best answer here is going to be H20 milliseconds. Why? Because we're looking at the start. It starts from the voltage of 50, dipping down to negative 50, and then coming back up to 50, and then we'll start extrapolating that it goes down to negative 50 and back up again. So it takes from the first portion from 50 to 50, it took 20 milliseconds completely. So we want to make sure that we understand what our period is as they define it and how we can locate that by looking at our figure. Okay, so far so good. Next up, number 23, according to figures 2 and 3, so we have to consider two different parts. Which voltage varied the least during the 20 millisecond interval? Okay, so looking at VS, VR, VL, VC, according to figures 2 and 3, lots to consider. Varied the least, what does that mean? Varied the least. So we want to see something that varied the least. What changed the least? Something that doesn't have a crazy up and down wave. So based on figure 2 and 3, figure 2 looks at VS and figure 3 looks at everything else. So which one of these guys over the 20 millisecond time period has the least range? Answer for number 23 is going to be C, VL. So looking at figure 3 VL, which is our dashed line, it doesn't go past positive 50 and negative 50. That's going to be the closest range we have versus what we have for VR or what we have for VC, or what we have for VS. Some of these guys go from 200 to 200 or negative 200 to 200. Or even a bit more than that. So we want to find the least variation here. Okay, polarity. They give us another definition, so let's pay attention. Refers to whether a voltage is positive or negative. A voltage of 0 has no polarity, can be ignored. Based on figures 2 and 3, again considering which two voltages were always opposite in polarity. So something that is when positive, the other was negative, and so on. Let's look at figures 2 and 3. We're comparing VR, VL, and VS and VC. Which of these pairs given from F to J is the best choice? And our best choice is going to be H, VL, and VC. Let's look at why. VL and VC. VL looks like the dashed line, and VC looks like the dotted line. It seems that whenever VL was positive, VC was negative. That means opposite in polarity, right? They're opposing. At 10 milliseconds, VC became positive, but VL became negative. So that relationship we needed to identify to correctly answer this question. So far, doing great. I see your answers. They are pretty good. Okay. 25. Based on figure 2, which of the following times was the current in which circuit flowing counterclockwise? Okay, remember that part in the reading that said what was counterclockwise and what was clockwise? It said positive current was clockwise and negative current was counterclockwise. So as this question asks, we need a negative current. So based on figure 2, which of these parts were negative? Okay, so our best answer for looking at figure 2, number 25, is going to be D, 15 milliseconds. Counterclockwise, negative. So looking at 15 milliseconds. Okay, last question, and then you guys get to practice one more time, and then I'll open the floor to some questions, comments, or concerns about the test. So number 26, the table below lists the electric charge in microcoulombs stored on the capacitor at 3 different times during the 20 millisecond interval. We have a little table here, time versus charge. Based on figures 2 and 3, from time 7 through 13 milliseconds, did the charge on the capacitor more likely change in sync with I or VC? This is a two-parter. We have to answer if it's I or VC and follow up with the reasoning. Our best answer is going to be J. VC over that time interval, both the charge and VC increased, then decreased. Okay, so looking at from time 7 to time 13, what's happening to the charge? It started at 51, went up to 0.87, came back to 0.51, and then we matched it to figures 2 and 3, the I part versus the VC part, and it seems like VC matched the best. Okay. You guys get to do one more section, passage 5, about strains of bacteria carrying a genetic mutation, from number 27 all the way through 33. So we have 8 questions plus some reading. I'm going to throw up a timer for, let's see, how about 9 minutes? I'm going to start the countdown. Let me know if you still have issues with accessing the document. I can send it one more time through the chat or into your email. Practice section, passage number 5. See where we get, and then we can go over. Then I'll open the floor up to some questions, comments, or concerns that you might have after the session. And let's give it a go. Starting for 9 minutes, counting down. So we're on page 19, passage 5, strains of bacteria. Sure, I can send that to you. 1 second. Okay. Ryan's gone. Let me know if that landed in your inbox. Yeah, I just hit send. Remember to critically read the passage, picking apart the question, identifying the elements that we need to look for, and looking for them in the right spot. Okay, reaching your halfway point. Make sure to check where you are. See if you need to speed up or slow down. We are just about at our 4-minute mark. Doing from questions 27 to 33. Counting down to our last minute. Let's look over our answers. All right, time is up. Let's see how we did. From 27 to 33, let's go over our answers. Okay, so this passage, passage 5, was about these strains of bacteria with genetic mutation that prevents them from synthesizing his amino acid, histidine, are called his negative. These strains of bacteria must absorb histidine from their environment in order to sustain their growth. Exposing his negative strains of bacteria to mutagens can cause new mutations that restore the ability of some bacteria to synthesize histidine. So I'm sure you guys all have read it. We have the study. What does the study do? So this little blurb up top above table 1 shows us what's happening with each dish from 2 through 5. So dish 1, as it's not mentioned in table 1, but dish 1 is the sterile petri dish that has the nutrient agar. Lacking histidine was prepared. And then his negative bacteria, which is S. typhimurium, was added to dish 1 and spread evenly over the nutrient. Then you did it for dishes 2 through 5, except something was different. Based on the results of the study, which of the suspected mutagens resulted in the greatest number of His-positive revertants in a dish? Looking at substance L, M, N, and P. Okay, so substance and which of the suspected mutagens results in the greatest number. So what do we have to do? We have to make some connections, seeing that what is the greatest number of his positive revertants are there. Number 27, best answer is going to be C, substance N. Why? Because we're looking at, firstly, the table 2 number of colonies. We want the highest number there, which is from dish 4. Going ahead and comparing that to table 1, what was in dish 4? Substance N. So C is our correct answer. Which dish in the study was intended to serve the purpose of testing whether some of the S. typhimurium cells became His-positive revertants without the addition of a mutagen? Okay, so which dishes 1 through 4, did not have that mutagen? Remember how I said that there was dish 1 containing that agar and then just the bacteria? That's the one we need to look at. Choice F. Because everything else, dish 2 through 4, the passage says they were mixed. They're mixed with one of the 4 suspected mutagens before being spread. So that was what's happening in dishes 2 through 5. Dish 1 is the only one without the addition of a mutagen. Okay. 29. Based on the results of the study, what is the order of suspected mutagens from the substance with the least potential to be mutagenic to the substance with the most potential to be mutagenic? So we have to rank them in some way. 29, the best answer is going to be B. Firstly, looking at P, L, M, and then N from least meaning P has the least potential and N has the most potential. We can look at the tables to connect which substance had how many number of colonies, and that's how we're going to rank them in order. Once we figure out from least to most, we can go ahead and correspond that to the order that they present us from A through Z. We have a question coming in. So the science section is basically just a test reading graphs and tables, easy 36. I'd like to say so. It's not super complicated. Like I said before, it was straightforward, right? You need to know what to look for. And it's different per section. The English, the math, the reading, and the science are all different techniques, which you can learn about if you join my class in January. So tonight is just our science overview, but we don't want to get too overly confident. We need to make sure that we read all parts, not skipping over those necessary details. So let's try number 30. In the study, the scientists tested the effect of substance P at a concentration of 5 by 10 to the negative 9 grams per milliliters after the study, so-and-so. Read the table, see how they relate from the concentrate to the number of colonies. What is the relationship? Hey, if any, between the concentration of substance P and its potential to cause mutations. Okay, so we need to find two parts. As substance P increases, what happens to the mutations? Number 30, the best answer is going to be F. As concentration of P, substance P increases, its potential to cause mutations increases only. How come? How come it's that? So looking at concentration of substance P, be mindful of what we are looking at in terms of the exponents. Sometimes the exponents are different, but since that's the same, we're noting that it goes from 10 to 50 to 100. That's increasing. Number of colonies, what does it do? It goes from 54 to 114. I'm not seeing a dip anywhere, so it's going straight up from 14 to 114, increasing. So as substance P, the concentration increases, its potential to cause mutations increases only. And then we have 31. Before the bacteria was added to it, the dish that was intended to serve as a control in the study lacked which of the substance below? So what did it not have? So 31, remember that dish number 1, that bacteria was added to it, but it didn't have any mutagens. What did it lack? It lacked both histidine and that mutagen. So answer choice D. What's the control of the study is something that you refer to in baseline without any manipulation. So that way you can refer to it and see what was different. Which of the mutagens caused more colonies or less colonies, but you have to refer it back to a control dish. That would be dish number 1 in this case. Okay, last two questions of the section. Which of the following statements about the numbers of bacteria regained the ability to synthesize histidine is consistent with the results of the study for dishes 2 and 3? The number of bacteria that became His positive after exposure to which of the substance, L versus M? Again, a two-parter. We need to confirm, is it M first, then L? Or the other way around, and what is the reasoning? So number 32, best answer is going to be F. Substance M was about 2 times the number of bacteria that became His positive after exposure to substance L. Okay, so let's go back to our tables. So we're looking at substance M versus L. Substance M was in dish 3. Dish 3 had 25 colonies. Okay, the L was in dish 2. Dish 2 had 14 colonies. Okay, so looking at our relationship, what happened, right? M as dish 3 had 25. Substance L, dish 2 had 14. What happened there, right? We need to find a relationship. Okay. So last question. The particular strain of S. typhimurium chosen for the study lacks normal DNA repair mechanisms. Which of the following statements give the most likely reason this particular strain was chosen? The scientists did what? Or did not want something. So here we want to go ahead and infer based on the experiment. So it's not going to be explicitly stated, but we can go ahead and take the information presented to us and make a conclusion. So the conclusion would be D. Wanted the bacteria in the study to be unable to repair the mutations caused by these substances. So we have to look back into the passage as they gave us and look at what the study, how the study did, and what was the results from table 1 and table 2, and then find the linking mechanism and answer number 33. Okay, so it is 8:52. Thank you for sticking with me for so long. I'm going to open the floor to some questions, comments, or concerns as they came up throughout my presentation, or if you have in general about the ACT, let's see if I can help you guys out. And let me know if you guys are interested in joining my class from January through April. I can help you out for each section. Similar methods of breaking things down and going over each question with timing for each test section. Let me know if you have any questions in the comments. Opening up the floor to you guys. Or questions or general tips. If you want to see something else, let me know. Anyone? Missed most of the session. Why is ACT opposed to the SAT? Is it just a science? Okay, so I'm going to see if Francis can send everyone the presentation so you can go ahead and, oh, the answer to the last question, sorry, number 33 was D. But the presentation is going to be available to you, and the beginning of the presentation is what breaks down the ACT test. So going all the way back. So overview of ACT, we have 4 different sections and an optional writing. We have an English, mathematics, reading, and science. Today we went over science, but we have all these sections asking for to demonstrate our foundational knowledge in English, math, reading, and science, and optional writing, timed differently with a different amount of questions per section. Why ACT as opposed to SAT? It depends on what you want to showcase to the colleges, right? I think ACT is going to be a more comprehensive overview of what you guys can do as students because it spans across 4 different subject areas. And that can help you, once you learn every section, what to do, what not to do, and what the content is, you will develop lots of critical thinking and critical reading skills to deduce what is necessary to answer certain questions. So like someone said before, science section is basically reading graphs and tables and picking out the correct answer or the best answer for the question to address the question. So I generally like the ACT better. It's a pacing test. It's a long-term pacing test, and the SAT just tests you on the English and the math part, the calculator and no calculator part. I generally prefer the ACT, so I like to promote the ACT to be the test that you will take to enter college. Any other questions, comments, concerns? We have 5 minutes left in our session. Thank you, Gigi. Thank you for coming to our science review. So you don't need a perfect to get a 36. Okay, so we have different score charts. So we have different score charts from different testing centers, but we take the best version and use it for our Kweller specific scoring. So I'm going to show you a little bit what the score breakdown might look like. I'm going to give us a second. Okay, so I'm pulling up the score chart. This is a sample score chart that you might see in how to find your raw score versus your scaled score. So reading raw score, science raw score is out of 40, math is out of 60, English is out of 75. So if you get, let's say 38 correct, your scaled score is only a 34. So some sections you do need a perfect raw score to get a perfect scaled score, which factors into your overall 4-section composite score. So as you can see, we go from the minimum number of right to the maximum number of right, which is your raw score, and then it'll translate over to a scaled score per section, and then we can average that to a composite score. Any other questions? Of course, we want to do the best we can in each section to get the best possible scaled score. So all your efforts are worth it. Any other concerns? We have 2 minutes left. I can answer any burning questions that you guys have, but also I got a 15, 20, corresponds to 34. Okay, so you want to compare SAT to ACT scoring. That is a different animal in itself. The question would be best answered by Frances if she can provide that sort of conversion to you. I don't have the materials for that, but in scoring, of course, you want to score the best you can to the highest score possible. Would it be easy to practice for the ACT? Oh, okay. So question was, if you're doing SAT, would it be easy to practice for the ACT? Both have time constraints, yes, but the ACT has 4 sections. It's going to be a little tougher to sit through all those sections because we will go from one section to the next. Let me bring back the PowerPoint. Because we're going from English straight to math, then a small break from reading straight to science, back to back. It's going to take a toll on how well you can focus, how well you can concentrate. So if you're training for the ACT, it's going to be like a long-term marathon. The SAT is going to be a little shorter run. So I think you build more mental character with ACT personally. And then there's that optional writing section. So if you're doing the SAT course, it would have some similarities for the English reading translation over to math as well. But that science section could really, really affect what your overall score is because the SAT doesn't offer that. And if you're translating that to ACT, you would need to have science test taking strategies as well. So the optional essay, I generally say yes, we can definitely try practice and work on that. We can take it just because I think it shows how well you can compose your thoughts and articulate yourself on paper in 40 minutes. So that's pretty impressive, I think, to colleges when they look at that. And also we can thank you, Ryan's mom. We can use all of this writing just to show, hey, you know, after 4 brutal sections, I was still able to do the writing part. I think that's pretty impressive. So yes, I would suggest essay, and essay is going to be a little different. In terms of review, I offer also private lessons. If anyone would like a one-on-one, we can do that. Just let Francis know. Otherwise, I can see everyone. Hopefully, if you'd like to, we can sign up for our January through April session. Do we have any last questions? Yes, no, no? Comments, concerns? Let me know how I did. I was a little nervous, but great to meet you all. Please, please, please make sure that you attempt the ACT. It's good for your soul. It's also good for colleges. They will see how you do, and that may factor into what comes next for you guys. So thank you guys so much for sticking with me for 2 whole hours practicing our science section. You still have one more section, the passage number 6. You can try that yourself. You have that answer key right in the back, the last page, so you can grade yourself. Otherwise, please have a great night. Be safe out there. It is snowy. So I hope you guys have a great evening. If you need anything, email Frances. She will be able to connect you guys with me, and I will give her the PowerPoint presentation so she can distribute it to you guys. So excellent meeting, everyone. I shall see everyone maybe on the next review or in my January class. Thanks, you guys. Have a good night. Take care.
Yeah, thank you so much. Bye.